So, like Karen just said, I am the site reliability engineer at Thumbtack. We're a small startup, but running really, really fast. And over the past year or so, we had to rethink a lot about how to provision servers, how to manage them, the whole development cycle, Puppet, and how to handle a couple of other different things. So I wanted to share that with everyone. But before, like, some context. So what is Thumbtack exactly? We are a marketplace for local service professionals. Say you need to hire a DJ or a photographer or a French tutor, well, some type of professional. You can just go to thumbtack.com, look for that specific category, enter your zip code, and we'll introduce you to a really good set of people that are going to do an awesome job. We know a guy to do it. You'll get a couple of quotes, and from that point on, well, it's your choice whether you want to hire someone or not, how it goes, the review, and so on. Kind of like the yellow pages without having to do the search for yourself and calling 10 people and judging the work without actually knowing them, and so on. And I can't really show any specific numbers, but this whole process of people going to our website and asking for a specific professional, we call that a request. And this graph shows the increase on the volume of requests over the last 3 years. It's a bit more than exponential, yeah. So this forced us to move much faster than we had anticipated. We have to adjust a number of things, and it's just not about deploying more servers. It's about the whole process that goes around it. Provisioning has to be fast and efficient. Destroying them also should be fast and efficient. That thing someone was mentioning earlier today of having nice, fluffy names and making sure that they have a cute personality and taking care of them when they get sick, that doesn't work. We also need to address that. The way people develop, write Puppet code and deploy, well, anything in production actually, that also has to be addressed and so on. So without further ado, this is a short description of our infrastructure currently. We have 40-something physical servers on colocation, some data center in Dallas. We have like 97 or so EC2 instances. We're trying to move everything to AWS. This is flexibility. Roughly half of those are for staging research purposes. We try a lot of things before actually changing something in production. We like to think of ourselves as a data-driven company. If the numbers don't show it, we don't do it. And we have pretty much everything managed with Puppet. Now there are a few exceptions. We don't deploy code with Puppet naturally. We don't do a couple of other things with Puppet, but the whole configuration management process is all around Puppet, like every single thing. And we wanted to add a few more things. So our goals starting, I don't know, like 8 months ago, maybe 10. We wanted to completely automate server provisioning. This was kind of a bottleneck. Some of that was manual, like signing the certificates, for example, bootstrapping the servers. It was really a slower process than we wanted it to be. We didn't have a proper development environment for the whole team. Writing new Puppet code, testing it and deploying it was really, really painful and not very productive. And we need to fix that, because otherwise we just have another bottleneck. And we also had to deal with the fact that we needed a good way to distribute sensitive information. Configuration files inevitably have API license keys, passwords, and a bunch of things that we really don't want to have on GitHub. It's just not good idea. And we need to sort that out as well. So that's what this talk's going to be about. Now, I'd like to stress that there are not like a million different ways of doing this. We were optimizing for trying to use as much as possible everything we already have. It's Puppet. Trying to take, well, again, advantage of everything AWS has to offer, specifically in terms of automation, and trying to solve the problem as fast as possible without getting into any more technical depth, because we had a lot of that at the time, and we wanted to remove it, not get some more. So we needed to get things done in the right way. But we didn't have a lot of time. And we didn't have a lot of people. We were 8 or 9 engineers at the time. The product needed to be shipped and maintained. So we had literally half a person to take care of all of this in like 2 weeks. And the way we solved this, or tried to address it, was 2 components. The first one, a custom AMI on AWS, with a simple shell script that takes care of the first step of provisioning, and then just use Puppet for everything else, and it should kind of work. So, some more detail about this. The custom AMI, we use Debian. That's our operating system's choice, well, since 8 or 10 months ago at least. We're running most of our fleet on Debian 7, but we do have a few running Debian 8 already. It should be released, I don't know, in a couple of months. It's current testing one, I don't know exact dates, but it's there, so we're working with it already. We just have a really, really simple minimal base system. The only changes we do to the Debian concept minimal base system is actually just including the contrib and non-free areas to the sources list files, because we do need a bunch of packages from those 2 areas, and they're not default. And we don't want to install suggested packages by default. They're usually just useless on the server at least. And that's it. Like, that's our base AMI from which we build everything. Puppet grabs pretty much empty server, and there's a little definition for each role of server, and everything else just happens for that one now. Now, in order to get there, we still need to fix a couple of things. So, like I said, we wanted to move fast and we wanted to keep things simple. The way we did that was by using really basic, almost naive, init script, System 5 style, that does a couple of things on the AWS side once you spawn a new instance using that basic AMI, which everyone can get. It's kind of Debian's defaults. It sets up the host name, it updates DNS records both forward and reverse zones. It runs the Puppet agent. This is kind of the tricky part. It will notify Slack. That's the tool we use for instant messaging. So whenever someone spawns a new instance, you get notified just because, well, honestly, because when we started this, having a new instance was kind of a relevant thing. Now it's just happens, no one cares, but it's still there. It uninstalls itself, because we really just want to provision the server once. Reboots the thing to make sure that everything is just as we want it to be, and, well, logs everything. Now, some of these things were kind of difficult to do with our current provider using physical servers, like setting up the host name of the DNS. We didn't have any control over the DNS servers. They have them. Our only option would be to deploy our own. There's no API to update it. Getting information like what's the IP addresses of the newly provisioned servers, it's possible, but just way too difficult. And all this is actually easy on AWS by using the metadata that they have. Some of that is custom, like the host name. Sometimes we do want to have our own host name there. We don't want to randomly generate this string. Again, metadata solves that problem. There's a nice user data field there we can use to specify whatever string we want and use that to provide a bunch of parameters, like host name, sometimes things like ZFS configuration options, because we do use ZFS with EBS volumes. And we also automated the part of creating tools and file systems and adding relation properties like compression, equivalence levels, and so on. All of that is really, really easy to get done using AWS. We just need to extract that from a specific endpoint that they make available to us with an HTTP request. We do manage our own DNS servers for now. We plan on changing that and moving to a 333, but at the time, that was the only option because they didn't allow us to have private zones, and we really don't want our private fragments to be on the whole DNS server. But from all of this, the part that really matters is running the Puppet agent, because, like I just said, we start with a basic empty server. It has nothing. This script will take care of a couple of things and goes on Puppet agent, but from that point on, we're kind of relying Puppet to do its thing and just provide us with a new front-end server, for example. That's a good example. The first challenge we had was the part of signing the certificate. We really didn't like the idea of having to stop or interrupt, pausing the provisioning step, logging into the master, checking the certificate, and signing it. On the other hand, we also didn't like the idea of just blindly signing a certificate when it comes, because not how things should be done. So we used a long-spaced sign. Those arrows were a lot nicer under this GPG drive, by the way. I'm sorry. So this is how it works usually. Let's say that bandit.internal there, like our new server, is being provisioned. The Puppet agent is being run for the first time. It generates a new SSL key and requests a new certificate to the Puppet master, which is appropriately named Puppet.internal. We'll run a policy-based DataSign script that will decide whether or not that certificate should be signed. If it decides it should be, well, problem solved. The agent will just continue to run on the new server side, and everything should just work because it will compile the catalog, download it, and apply it. What we do here right now is just a couple of basic checks. We figured that adding a new gigantic layer of security was kind of useless because this happens already inside our own internal network. So if someone actually hacks some of our servers and is inside our private network and has access to everything we have there, provisioning a new server is the least of our concerns. Having a new Puppet agent running is also a very, very small concern. So we had very little time. We wanted to check a couple of things. These are a few examples. I don't know exactly what else we check now. The script has evolved. We started by just making sure that the cert name was provided, that it was not a duplicate, that there was another hostname running with the exact same hostname, like a couple of basic things. All of this can be extracted out of AWS API, and that should be enough actually. This is an external script you can have with Puppet. It can be written on any language, I believe, like just has to be binary. It runs every time a certificate is requested. So right now, having this, we have provision taken care of. Right? That's one solved problem. We have an empty image. We create a new server from that. We have a nice shell script, an init script that will do a couple of things to prepare it. Install the Puppet agent. Obviously, make sure that the API for Puppet.internal is available. Requesting certificate, it should be auto-signed. And from this point on, assuming the node definition is correct, and the Puppet code itself is sane, give it like 7-10 minutes, and you have a new front-end server. It just works, nice and simple. Now, the next step is actually managing this, because like I said, this is assuming that the node definition is correct. And even after the server has been provisioned, we need to maintain it. We need to change things, and the team was growing. It's still growing. We're hiring, by the way. We didn't have like the best possible development cycle. This is how things used to work. We had one Git repo, which is nice. The code was under version control. We had one single Puppet master, which is common. No big deal there. And we had no staging environment, which I honestly don't know if it's common or not. Actually, this is a good time for a call. Like, who has a staging environment here for Puppet? Who tests things before pushing them into production? Okay, it's a nice number. Small, but nice number. Because every single place I've worked at before did the exact same thing. Like, this was not there. So the cycle will be something like write code, you commit code, you push it, you update the master, and you run it into a dry run on some node. And then you'll see something like this. Syntax error. I'm sorry, my people in the back are not able to see this. It's just a bunch of errors like, it's either a syntax error, or could not find the class, or there's duplicate declaration, or dependency cycle. These are all things that if there actually existed, like if we had a staging environment, if we had a way of testing the code somehow before deploying it, well, everything would be much easier. It's like what we do with any other programming language, right? Like trying Python, Haskell, Erlang, wherever. You're going to write the code, test the code before you actually push it into any branch on any version control system, or even asking for a code review. Well, this wasn't the case, and we also to fix that. People should be able to write code as fast as possible and push it as fast as possible, and make sure, like, feel comfortable they're not breaking anything with it. This is how we address this part of the problem. Let's say we have this environment. Bender and whatever and Fry are just servers we have. Puppet is the Puppet master. We have GitHub there and a bunch of development instances on which people work. Besides cloning the repo and being able to edit files locally and have it in version control and push it, we added, we made all of those servers Puppet masters. So now each developer has his own or her own Puppet master. They can test things locally. It's, again, a really simple thing to do. We just need a couple of configuration options. We have to say that it's not certificate authority, and we need some alternative DNS names. But those are the 2 settings that go into the configuration file. Really simple. And just by doing that, you're actually able to test changes locally or from staging box or from wherever. Like you're changing code on your own box, maybe even, well, not your laptop, that doesn't work. But since we're on AWS, we have cloud instances there, and each developer has its own. Just log into it, change the code, test it. You'll catch all the errors I've shown before. It's much more a much more common way of doing things actually, because now you can just write the code, test it, change it appropriately, then commit, then send the code review, then push it, and then update the master, like the real master, and let things happen. Because another small detail we used to have to be concerned about was not having the agent running. We had to have, like, it just wasn't an option. If we had the agent running and sometimes it was something that was not properly tested, it could break production. We couldn't accept that. So the whole thing was just a manual process. After carefully going through all of that and testing things and making sure that nothing breaks, we would have to manually run the agents on every single server. When we had 5, no one really cared. When we had 20, people were upset. When we got to 50, no one had the patience, actually. And that also meant that people were not as careful as they used to be. So with 10 servers, people were actually careful at the output of my run, seeing, hey, okay, it's going to change this, it's going to restart that. With 50 servers, no one really cares what's going to be changed. It's like, yeah, apply. And then, oops, I'm restarting the database server. Not ideal. Less than optimal. So being able to just let the agent run in production and make sure that things get updated and everything will just work was a huge part of this. Just like having our own Puppet master. So now we have a way of provisioning a server and actually maintaining it without people stepping on each other's toes or being constantly afraid of changing production. That was another issue we used to have. Like people were afraid of changing things because they could break things. And no one wants that, but that's also preventing us from moving, and we needed to move fast. So, too many problems. The next one, sensitive data. Like I said, we inevitably end up having passwords, license keys, like a bunch of things in configuration files, and those need to be there. Like, there's a bunch of things we just don't want to push into GitHub. We can't. Like, the repo itself is cloned on every engineer's laptop at least. So it's like 25 copies of that data. 25 copies of the same password is just a bad idea by itself. And we knew what we wanted. we wanted it to be easy to use with Puppet. Like, no one should have to suffer to get access to the value of a password. It shouldn't require another password. There are a few solutions that ask for this, but it's just getting from one problem to the equivalent one. We don't have a way of securely storing passwords, and if we try to protect that with another password, well, we get to the same question, actually, how we're going to store that password. And we also wanted this to be simple and easy to understand, because if it's not, someone's going to mess up inevitably. And passwords. How do you address all of those? Well, easy to use. They have to be variables. If all of that data is just a bunch of variables available to Puppet, it's easy to use. Whoever's writing Puppet code will just have the variable, and we're good. Don't require another password. We're using AWS, and they have this really cool thing called IAM roles. I don't know how many of you are familiar with it. Another quick poll. Who knows IAM roles? Okay, not enough, so I'll just go through it. It's really cool feature they added. I honestly forget what the acronym means. Identification and something management, account management, probably. That actually means that you can create a role which is kind of a set of permissions for a given object. That object could be a dynamo table, an S3 bucket, an EC2 instance, anything, some object. And you can allow some other object to access it. And then AWS API will manage all of that for you. So in our case, we want to protect our passwords, which will be stored someplace. We'll get to that later. And we want one specific server to have read-only access to that. So we have an IAM role which grants that. That server, whenever necessary, requests the AWS API access to that object. Role will allow it, it's going to be provided, it's secure, and we don't have to manage another password. It's taken care of for us. Easy to understand, again, this is S3, so the simplest way of storing a key value pair like passwords for service X would be either S3 or Dynamo. We started with S3, we're now considering moving to Dynamo for performance reasons. Turns out copying files and opening them adds way more overhead than we wanted it to when things scale a bit. But honestly, it's the exact same concept. It doesn't make any difference. Just changing the backend. So this is how we do it. We're storing the data on an S3 bucket right now. The name of the file is the name of the password we want to keep, or the let's say license key. That's an easy one. So we use Twilio for sending SMSs. We need to store a couple of passwords for Twilio. So Twilio password is going to be the file name, and the contents are going to be the license key we have to actually use that. Like I said, we have one IAM role with read-only permissions, which we grant to the Puppet master instances. The other instances also have access to that. And something happened, which doesn't look good. There's still one small problem here, which is how exactly are we going to get the data out of the S3 bucket and make it available to Puppet as a bunch of simple, easy-to-use variables? We can just use an external node classifier. It kind of fits like a glove here. It's, again, another quick poll. How many of you are familiar with external node classifiers? Okay, I'll explain it briefly. It's again a script. It can be written on any given language. It just has to be a binary thing that the Puppet master will execute every time an agent runs and requests for its catalog. So what we do here with this, on every Puppet run, the agent will request the catalog. So the master will run that script, the external classifier one. In our case, it's a simple Python script. The host name is passed as a parameter. So what that script does is it connects the S3 bucket and it gets all the sensitive data, all the sensitive information that's relevant for that node. And it makes it available as top scope variables for that node. So when the node gets the catalog, it can do things as simple as this. So we have a class called Datadog, which is one of our monitoring tools. The API key is just that, Datadog underscore key. Whoever's writing public code doesn't have to be worried about where that comes from. It's just there. On the other hand, whoever's managing the S3 bucket or dynamo table doesn't have to be worried about public as long as they respect that that interface and make sure that the external classifier will provide the mapping. Like it works by providing the mapping between the files on S3 or the dynamo tables and the variables. On templates, things are also easy. Our public dashboards database is also on RDS and Amazon. So one of the things, one of the files we have to manage is that one, and it does have a password. So this is literally a piece of our code. Just add public dashboard underscore db underscore password. It's there. That's simple. So taking a step back and looking at the global picture, what we now have is a way of provisioning servers without getting interrupted. We spawn a new server from the command line using that specific AMI. We set up the appropriate host name and we just wait. And Puppet will take care of everything, including those modules that require access to sensitive data. Not even that will require anyone's attention or typing extra passwords or anything else. Again, just wait 5 or 7 minutes and you have a new server up and running, good to go. Now, the only problem we found with this is that sometimes, like this is really kind of suboptimal. Imagine we have 10 front-end servers running and we need 2 more. Using this process, it does work, like it's more of the same, but it feels like a bit of a waste. If we have 10 front-end servers running and they're like just, running there, good to go. We just ran Puppet 2 hours ago. Why go through the whole process of actually getting an empty server, provisioning from scratch, and letting Puppet install all the packages, all the files, all the configuration options, and so on? Kind of feels a bit of a waste. So this is what we can do by just reusing everything we still have. Remember, time was not much. We wanted to optimize for doing the best we could with everything we had. So we still have that provision script, and this is what we can do. We can just clone one of those, like take a snapshot of one of those running servers, redeploy the provision script, and create a new AMI from that. Now that new AMI is going to have not an empty base system, but a full-featured front-end server. If you use it now, the Puppet agent will actually do nothing because it was already running. If you use it 2 weeks from now, granted, a few things have changed, but it's going to be a lot faster to let Puppet run and apply the differences between our front-end servers 2 weeks ago and now than to rebuild the whole thing from scratch. So by doing this, by just doing this, we can actually use the exact same process, everything we have, no more code, no more process around this, no more things to learn. We can just reduce the time to a couple of minutes, which is pretty cool to us. So in conclusion, we have right now each developer with his or her own Puppet master. They are like the masters of their own destiny. They can do whatever they want without being afraid of influencing anyone else's work, staging, production, whatever. They can just literally trash the whole thing, and if they need to, they can just respawn a new test instance. And by the way, this is the process that built it. And they wait for like half an hour, and they have one. They can easily test changes either locally or from staging boxes or wherever. Just point the agent to the Puppet master, and it works. Development can happen in parallel. This was, again, another major boost to our productivity. We no longer have to be worried, like, are you editing that file? Like, worst case scenario, if 2 people do happen to just touch the same file, someone will merge it. Just, again, as you do with Python, Go, Haskell, whatever. We don't need to babysit agent runs. It can just happen, and you don't get to sleep. And we feel like we really didn't invent anything. We're just using standard tools in a way that kind of addresses all those problems and allows us to move quickly without having to go into those. I don't know again how many of you are familiar, but Netflix is usually kind of an extreme example of how to do things on AWS by having custom everything. That sounds good. Everyone always wants to go that way, but we're not that big. We don't have that many resources, and we actually need to solve use problems. And we felt that AWS on one hand and Puppet on the other one, we could just combine features from both of them, and everything just worked. And it did, for us at least. So, thank you for listening, and any questions? Sure.
I was wondering on the, like 2 slides ago, you mentioned that you take a snapshot or create an AMI based on some state. Mm-hmm. How do you manage the state? Like, do you actually have some automated way of creating a snapshot or creating a new AMI every few weeks or something like that, or is that manual?
No, for now it's manual. We don't care about the state. It's about the type of server. So as long as it's, using the same example, a front-end server, we couldn't care less what state it's in. Like whether the Puppet agent ran now or yesterday, it's all the same. It's gonna be updated anyway. Just a matter of changing 2 files, 10 or 15. We don't care.
But then how often do you refresh the AMI?
It really depends on, of course. So the question was, how often do we refresh the AMI? It really depends a lot on what we're talking about. For example, the base one we have that builds everything is refreshed, I don't know, once every 3 months, as far as I can remember. Our own test instance, for example, well, mine has been refreshed twice a week at some point. It really depends on how often things change. But since the process is kind of manual and independent, we haven't automated that. It's pretty much whenever someone feels that they need a new one, they can just log into the console, right-click, create a new one, and wait. Oh, of course, they have to spawn another one afterwards, and then wait. Yes?
You're using it to provision your AMIs, but do you also use it to do things like create security groups in AWS or create load balancers and all the other pieces that go around those AMIs?
Okay, so the question was, are we also using this to take care of security groups and everything else that goes around, massive load balancers and everything else that goes around the AWS ecosystem? The answer is no. We use other tools for that. Puppet is just about configuration management for us. For deploying some things, for example, we use Fabric when we only need like a parallel message thing. For deploying fancy things on AWS, we either have other tools that automate part of the process, or we use something like Elastic Beanstalk, for example. And that's where we have part of the load balancers and security groups and everything else. This is for configuration management only, nowadays. Yes?
Kind of related to that, the checks you were talking about when you were issuing certificates sounded like they were strictly related to machine identities and not to the identities of the person who was operating the script and, if you will, kicking off the process that made the request. Is that a true statement, and is that a hold?
Okay, so the question was on the part of auto-signing the SSL certificate. It felt that we were only checking for the machine's identity and not the person running the script. And the question was, is that a true statement, and whether that's a good idea or not? Okay. So yes, it is a true statement. We don't do any kind of checks on who started the process. The reason for that was that, quite honestly, and please don't follow this example, at the time we really didn't care. Like I said, we were 8 or 9, and 3 people probably were using AWS. So just by looking to the person next to you, you would know what was going on, and that was not one of our concerns. After that, we have enabled things like AWS config and CloudTrail, which allow us to, let me take this a step back. So there is actually no easy way at that level of verifying other thing other than the machine's identity. So that's why we took the easy way to that. However, by using other tools, other APIs Amazon has, like CloudTrail, for example, we can trace what's happening with that machine's identity to someone else and see that, for example, hey, Marco just spawned this server. And then we can actually verify whether that person is authorized or not. Right now, that's starting to be a problem for us, so we are looking into it, and that's probably going to happen. We're going to add a bunch of those checks to that script. It's going to be expanded. But for now, we don't have it.
All right. As sort of a follow-up, are there any considerations of using mechanisms other than passwords for a lot of those security checks or protections that you were talking about?
So as a follow-up, is there any other mechanisms other than passwords for the security checks? Are you referring to what security checks exactly? Like the last part on storing sensitive data? Or?
Yeah, you were that in particular. Okay. I mean, you talked about one single password that you were specifically not storing in Git, but you had a bunch of others that you weren't addressing.
Oh, I'm sorry. So it looks like there's the impression that I was talking about a specific password. No, that my bad. That was supposed to show a way of storing any password you might need to store. Like I gave that example because it's one of the passwords we have, and it's for the Puppet dashboard. But we have a ton of them there. We have license keys for all third-party products we use, all the products. So the short version, or the short answer to that question is, every single configuration file we have that needs a password or a license key or something like that, that value gets stored using that mechanism. Okay. Every single thing.
So you don't use PKI for that to solve that problem?
No. Do you have a question?
Is that auto signer
is the script open source? No. We want to. It's just there's a lot around it. That it's not easy to. Unlike other things, it's not just hey, I'm open sourcing it. Here's the license. It's public on GitHub. It has to go like through a bunch of authorizations, and it's still not there. We want to open source as much as possible. We always try to do so, but this kind of touches some of our internal stuff and something we just can't show. So we're trying to figure out whether it's reasonable to just release it, or we should have like a subset of it open source and then just add a couple of our own things on it. But that's the goal. Yes?
Let's say today you want to add a new password that will be used by the front-end server.
Mm-hmm.
How would you go about adding it to your S3 bucket? Is that manual or is it on a way for it? And how do you add it to the role or that's for the role for the front-end server?
Okay, so the question is, how would you go if now we had to add a new password to that whole system, say for a front-end server that needs access to SendGrid. So the short answer to that is it's a manual process. There's only one group of people that Thumbtack have permission to access that bucket, and it's engineering. No one else is allowed access. Again, we recently enabled CloudTrail, and we're planning on tracking everything that happens there for obvious reasons. But it wasn't the case up until a month ago or so. That's also integrated in our monitoring system right now, and we plan on adding a couple of alerts like, hey, this was added, or hey, that was changed. Just like a heads up, because it's sensitive data. Once that's stored in the proper place, like once the file is placed there, on the Puppet side, there's really nothing you need to worry about. The external load classifier will get the data and make sure that the variable is there. So you just need to map the name of the file to the name of the variable. That's it. Like if someone uploads a file called front-end SendGrid password, and you use on your template at front-end send with password, it's just gonna work. You don't have to do anything else.
But I still need to go to the template and add the value.
Well, yeah. Yes.
Have you considered using a continuous tool so that you can develop this simple
For Puppet? No, not really. Someone thought about it, but there was actually no kind of clean solution there that could like fit our environment easily. So we use it for everything else actually. Puppet was by far the most neglected code base we have. By far.
What about containers? So that you can focus on testing.
We use Vagrant sometimes. I didn't mention that around it, but yeah, we do that. On the part of testing things, like when I said I don't locally or some staging box, you can just use one of our staging boxes, of course, but spinning up a new Vagrant instance and pointing it to the Puppet master and seeing, like, testing it is something to do, yes.
Perfect. Thank you so much.
Thank you.